Introduction. Hey, Saurav, look at that building. Yes, that is the highest building of this area, you know. Look at that flag over that building, man. Do you know that we can easily find the height of that flag and the building? Really? Yes. We use trigonometry ratios to find the heights and distances. Come, I will tell you in detail. Objectives. At the end of this lesson, you'll be able to understand the line of sight, define angle of elevation, define angle of depression, solve examples related to heights and distances. Angle of elevation. Sometimes we are required to find the height of a tower, tree, building, and distances of a ship from lighthouse, width of a river, etc. We cannot measure them accurately, though we can find them using the knowledge of trigonometry ratio. The word elevation means rise or move up. Angle of elevation is the angle between the horizontal and the line of sight to an object above the horizontal. Let us take an example to understand this. In this picture, an observer is standing at the top of a building and looking straight ahead at the birds which are in the horizontal line. The observer must raise his eyes to see the airplane which is in the slanting line. This line is also called as line of sight. The angle formed between the two lines is called the angle of elevation. Hence, angle of elevation is the angle between a horizontal line and the line joining the observer's eye to some object above the horizontal line. Angle of depression. Now consider the situation when a boy is standing at the cliff and is looking down at the boat. Here the line of sight is below the horizontal level. So the angle formed by the line of sight with the horizontal is called the angle of depression. Thus, the angle of depression of a point on the object being viewed is the angle formed by the line of sight with the horizontal when the point is below the horizontal level. Example 1. Let's solve some examples to understand better about angle of elevation and depression. The angle of elevation of the top of a pole measures 48 degrees from a point on the ground 18 feet away from its base. Find the height of the flagpole. Let's first visualize the situation. Let x be the height of the flagpole. From triangle ABC, tan 48 degree is equal to x upon 18, which implies that x is equal to 18 into tan 48 degree, which equals 18 into 1.11061 and so on, which is equal to 19.99102 and so on, which equals to 20. So the flagpole is about 20 feet high. Example 2. An observer 1.5 meter tall is 28.5 meter away from a chimney. The angle of elevation of the top of the chimney from his eyes is 45 degrees. What is the height of the chimney? Solution. Here AB is the chimney, CD the observer, and angle ADE is the angle of elevation. In this case, ADE is a triangle, right-angled at E, and we are required to find the height of the chimney. We have AB equals AE plus BE equals AE plus 1.5 and DE equals CB equals 28.5 meter. To determine AE, we choose a trigonometric ratio which involves both AE and DE. Let us choose the tangent of the angle of elevation. Now tan 45 degree equals to AE upon DE, that is, 1 is equal to AE upon 28.5. Therefore, AE is equal to 28.5. So the height of the chimney AB is equal to 28.5 plus 1.5 meter, which equals 30 meter. Example 3. The angle of depression to the bottom of a canyon 67 meters deep is 40 degree. To the nearest tenth of a meter, how far across does the canyon stretch? Again, start by drawing a diagram. Remember, the angle is 40 degrees from the horizontal. We can now use a trigonometric ratio to determine how far the canyon stretches. We have the option of using one of two trigonometric ratios, tangent or cotangent. Either way, we will obtain the correct answer. Let's use tangent. Tan 40 degree is equal to 67 upon x. X into tan 40 degree is equal to 67. X is equal to 67 upon tan 40 degree. X is equal to 79.76 meter. Therefore, the canyon stretches 79.76 meter across. Example 4. A person standing on the bank of a river observes that the angle of elevation of the top of a tree standing on the opposite bank is 60 degree. When he moves 40 meter away from the bank, he finds the angle of elevation to be 30 degree. Find the height of the tree and the width of the river. Solution. Let height of the tree be y and width of the river be x. CD is equal to 40 meter. In triangle ABD, tan 30 degree is equal to AB upon BD. 1 upon square root of 3 is equal to y upon x plus 40, which implies x plus 40 equals to y into square root of 3. Equation 1. In triangle ABC, tan 60 degree is equal to AB upon BC, that is square root of 3 equal to y upon x, which implies y is equal to x into square root of 3. Equation 2. Putting value of y from equation 2 to 1, we get x plus 40 is equal to x into square root of 3 whole into square root of 3, which equals 3x. On simplifying, we get 40 equals 2x, which implies x is equal to 20 meter, and y is equal to x into square root of 3. On putting the value of x, we get 20 square root of 3. Therefore, height of the tree is 20 square root of 3 meter, and width of the river is 20 meter. Example. The angles of depression of the top and the bottom of an 8-meter tall building from the top of a multi-storied building are 30 degree and 45 degree respectively. Find the height of the multi-storied building and the distance between the two buildings. Solution. Here PC denotes the multi-storied building and AB denotes the 8-meter tall building. We are interested to determine the height of the multi-storied building, that is BC, and the distance between the two buildings, that is AC. Look at the figure carefully. Observe that PB is a transversal to the parallel lines PQ and BD. Therefore, angle QPB and angle PBD are alternate angles and so are equal. So, angle PBD is equal to 30 degree. Similarly, angle PAC is equal to 45 degree. In the right triangle PBD, we have PD upon DB equals tan 30 degree, which is equal to 1 upon square root 3, or BD is equal to PD square root 3. In right triangle PAC, we have PC upon AC equals tan 45 degree is equal to 1. That is, PC is equal to AC. Also, PC equals PD plus DC. Therefore, PD plus DC is equal to AC. Since AC is equal to BD and DC is equal to AB, which equals 8 meter, we get PD plus 8, which is equal to BD, which equals PD is square root 3. This gives PD is equal to 8 upon square root 3 minus 1, which equals 8 into square root 3 plus 1 whole upon square root 3 plus 1 into square root 3 minus 1, which is equal to 4 into square root 3 plus 1 meter. So the height of the multi-storied building is 4 into square root 3 plus 1 plus 8 meter, which is equal to 4 into 3 plus square root 3 meter. And the distance between the two buildings is also 4 into 3 plus square root 3 meter. Did you know? Surveyors have used trigonometry for centuries. One such large surveying project of the 19th century was the Great Trigonometric Survey of British India, for which the two largest theodolites were built. During the survey in 1852, the highest mountain in the world was discovered. From a distance of over 160 kilometers, the peak was observed from 6 different stations. In 1856, this peak was named after Sir George Everest, who had commissioned and first used the giant theodolites. This is a theodolite, a surveying instrument which is based on the principle of trigonometry, is used for measuring angles with a rotating telescope. The theodolites are now on display in the Museum of the Survey of India in Dehradun. Summary. Let us summarize what we have learned. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The angle of elevation of an object viewed is the angle formed by the line of sight with the horizontal when it is above the horizontal level. That is the case when we raise our head to look at the object. The angle of depression of an object viewed is the angle formed by the line of sight with the horizontal when it is below the horizontal level, that is, the case when we lower our head to look at the object. The height or length of an object or the distance between two distant objects can be determined with the help of trigonometric ratios.